Welcome to the Tech Talk. Let me share my screen. So I will be talking about vertical alignment in CSS layouts. First of all, I wanted to say that if you have any questions, feel free to interrupt me during the presentation if anything isn't clear or if you wanted to add something. Second, I wanted to say that I will be talking about things that I learned from my colleagues in the past year, and also I will be using some illustrations that I have stolen from some articles. There will be links at the end. Okay, so I think like a few years ago, designers or front-end developers started using something called vertical rhythm. In my understanding, vertical rhythm is an approach to building layouts in a way where heights of elements and spacing are multiplies of a predefined value. So basically, the approach is to build layouts that look like that. So we have like visual rhythm and things are evenly spaced. And it's not very hard to approach to have a system like that, because basically a simple approach is to just have line height set for all the content on our page, and to ensure that elements heights and any white space between these elements is multiplies of it, and maybe pay attention to borders and subtract accordingly. And there are lots of articles on the web on how to implement that. So the end result looks, for instance, like that or like that. So here is a page with vertical rhythm of, I think, 18 pixels. And we can see that everything falls between these lines and looks harmonically. And this is not what I wanted to show in this presentation. So I wanted to focus on something a little bit harder to achieve in CSS. So first, there is a problem with line height. And the problem is that if we use line height, we can see that the content is centered between lines. Here's another example. So we have some lines or another example, and regardless of the font size, the browser will try to place the text in the middle of the line vertically. I will explain in more detail what exactly it means. So this isn't what we wanted to achieve, because what we really want is to have something that looks like that. So we wanted to have the text baseline, so the line that goes at the bottom of the letters. Maybe I'm not very precise, but I hope it's intuitive. So we want to align the text by the baseline. So we want to have something that looks like that. And if you are using our pilot application, if you look very closely, you may notice that this is exactly the way that this application has been built. So so anything that we display in the application is aligned to these lines that I have enabled for debugging. So we can zoom in and we can see that, for instance, this heading is aligned exactly as this heading here. And of course, it's like a design choice, and you may like it or you may not like it. I would say that it's like pleasing to the eye, and I like how it looks. So I think it's worth the effort. Okay, so the question is how to achieve this kind of vertical alignment. The bad news is that there is no direct way to do it in CSS, because as I said, the way the line height property works is that the text will be centered vertically. So we have to do it manually. And to do it manually, we just need to shift text by the appropriate number of pixels. So first we need to determine how much we need to shift it. And second, we need to find a way to do it in a way that won't get in the way too much. So first, how to determine how much the content should be shifted. And I had a picture and I have closed it before. And there is line height that is indicated by these top and bottom lines. And when we have the text, the letters have something that is called cap height. And cap height is the size of a capital letter. So we can imagine if there was a capital A, the baseline is the bottom of a capital A, and the cap height line is the top of the of that letter. And in order to move the baseline of our text to the bottom, what we need to take into account is the cap height and the line height. So basically what we need to do is we need to, where is that? So basically what we need to do is we just need to get the line height, subtract the cap height, divide it by 2, and we will have this distance like this, and we can move it to the bottom. So first, how do we determine the cap height of a font that we are using? Basically by experimentation. Because cap height is a property of the font that we're using, so if we switch font, it will have a different cap height. I don't know if there is a way to determine that programmatically, but it's quite easy to just try different values and find out which value will end up with correct alignment. So I will show how it's implemented in our application. First, we have a list of font sizes. So we give these font sizes names like XS is extra small, S is small, M is medium, and so on. And second, we use different fonts at various sizes. So for small text, we have a different font stack, and for larger text, we have a different font stack. And we have a set of cap heights. So 0.8 is a value that we have determined for the smaller sizes, for this font that we use at smaller sizes. And this 0.68 is a value that we have determined for these larger font sizes. And I have a SAS function that looks like that. And this function just calculates the correct offset for a particular size. So the way we use it is when we call rhythm shift and we give it a name of the size that we need. This function will return the offset in pixels. So the way it works is just as I described. So we have the line height, which is a constant of 24 pixels, and we have the cap height as a fraction of the font size. So we multiply it, and then we divide it by 2. So this is exactly the calculation that we described when looking at this picture. In real world, it's a little bit more complex because we have varying line height depending on the font size. So when we have very, very large font sizes, we switch the line height to a larger value, but this isn't relevant here. So so this is the calculation, and we have the correct offset. So now we have a question of how to apply this offset and how to actually move the text so it looks like in this picture. I know 3 ways to do it. There may be other options. I think these are 3 reasonable ways, and I haven't used the first one, but I will discuss it briefly. For a few months, we have been using the second one, and recently we have switched to the third one. And I think the third one is like it's not it has its drawbacks, so it isn't perfect, but it's I think much better than the previous options. Okay, so the first option that we can imagine is to have position relative. So let's say we have a class called rhythm M, like for the medium font size. By the way, I'm using the name, the word rhythm. It may be not like totally correct word for that, but that's how our class names are in the code. So the first option would be just to apply position relative and shift stuff by the certain number of pixels. We can try it in this first example. So let's say we have this element and we would like to shift it. So we can do it like that. And we determine that 6 pixels is the correct amount, and now we can see that it sits on the lines, on the grid lines that we are using. So this could work, but this approach has several drawbacks. And I think the two biggest drawbacks are that first, we may want to use positioning for different purposes because it's quite a useful property. So if we use position relative for rhythm, we may have a problem when we want to use it for something else. And second problem, and I think it's a bigger problem, is that positioning may affect that indexing. And what I mean by that is when we have two elements that overlap because maybe we have some negative margins or maybe they overlap for some other reason, when we start applying position relative, these elements will be placed on top of those that don't have position relative, and things may get messy. So that's why I would rule out this solution. It's not a bad solution, but I think it may cause problems. So the second solution is the one that we have been using for a few months, and actually is the solution that is recommended by this article. And so the idea is that when we need to shift content, we apply padding top to the element. So we can see that now this element sits on the grid line. But now we can see that content below has also shifted, and it's not what we wanted. So we have to compensate for that, and we apply a negative margin bottom. Now the second element is back where it wanted to be, where it was initially. So this way we can align each element separately. So in this case, it will be probably 7 pixels because it's a smaller font size, and so on. So this approach worked for us quite well. There is one very important thing is that margins in CSS are collapsing. I will explain that in more detail in a minute. But basically, to use this approach where we use margin bottom to compensate for this padding at the top, we had a rule that we never use top margins anywhere in our CSS. I must admit that we have broken this rule like maybe 1 or 2 times, but basically we're always trying to never use top margins. And by the way, it may be a good idea if you have margins in your style sheet. It may be a good idea to make a decision whether you use always top or always bottom margins and stick to that, so you will avoid problems with collapsing margins. With this constraint, it worked quite well, but the problem is that sometimes we wanted to have a padding applied to an element. So let's say we have this heading, or maybe this one, and we wanted it to have like maybe 12 pixel margin padding at the top. So what we had to do was to somehow make a calculation, and instead of applying 12 pixels, we needed to apply 18 pixels. And it's not extremely hard to do because in SAS we have calculations, so we can always make these calculations. But the problem was that we have utility classes for applying paddings, because sometimes you just need to apply a padding, and it's handy to have such utility classes. So the problem was that these utility classes needed to take these rhythm adjustments into account, and the end result was that we had a lot of special cases like that. So when we have rhythm M and we apply some padding top, we need to take this rhythm into account. And as I said, it's doable in CSS or in Sass, but the complexity grows very, very quickly. And the end result was that our style sheets were bloated. We were abusing at extend in CSS, and overall we ended up having some bugs, and it didn't work very well. So, so there is a third approach that wasn't my invention, but it's pretty cool. So the third approach is to use margin top and margin bottom. So I will show how it works. So let's say we have this element and we apply some margin top. Now we apply some margin bottom. And we have the next element and we again use margins. You can see that it works properly, but I mentioned collapsing margins just a few minutes ago. And it's interesting because this approach solves the problem with collapsing margins in a clever way. So first I will show what are collapsing margins. So let's say we have two elements, the red one and the green one. And let's say the first element has a bottom margin applied. Let's say it's 50 pixels. And the second element has, again, 50 pixels applied. So one could expect that the distance between these two elements would be 100 pixels, but it's not. Because CSS specifies that if you have adjacent elements with margins, the margins are collapsing. So basically, the bigger margin wins. In this case, they are equal, so it's just 50 pixels between those two elements. There is a second case where collapsing happens, is when we have a parent and a child. And in this case, the parent element has, if I remember correctly, 50 pixels, right? Oh, actually it doesn't. Okay, so basically, it does or it doesn't. Okay, it doesn't, but if it did, I think it would also happen. So basically, when we have a parent that has 50 pixel margin, and we have a child that also has 50 pixel margin, they again collapse. So instead of having like 100 pixels or maybe 50 pixels within the red element, we have only 50 pixels at the top. So that's the second case where collapsing applies in CSS. Okay, but we're more concerned with the first one, so we have two adjacent elements. So how does it work? So the rules specified in the CSS specification say that if you have two adjacent elements with positive margins, the bigger one wins. So let's say we have one with 30 pixels and the second one with 20 pixels. So the end result is that we will have 30 pixels margin. So this means that mathematically it's just maximum of these two values. If we have negative margins, it's the lower one wins. So like here is minus 30 pixels, here is minus 20 pixels. So it's minus 30 pixels in the end. So mathematically, it's like taking minimum of these two values. But if we have a positive and a negative margin, then it's just a simple addition. So if we have, let's say, 30 pixels positive margin, and then we have minus 20 pixels, the space between these two elements will be just 10 pixels. So it's like 20 subtracted from 30. And it turns out that if we stick to always having this third case, so if we always have alternating positive and negative margins, things will work properly for our rhythm adjustments. So Yeah, so I have more examples if you're still following. So if we used a margin somewhere other than our rhythm classes, let's say we had an element that has a margin bottom of 10 pixels, and after that we have our element that has a margin top of 6 pixels. After the margin collapsing, it will only have 10 pixel space. So this means that from now on we will be off by 4 pixels. So we don't want that. But if we didn't have any like elements that get in our A, and we only in our way, and we only used our rhythm classes, and we only had margins in our rhythm classes, then it would work properly. So if we have one element that adds a negative bottom margin, then we have the next element that has a positive top margin. After subtraction, it's just 1 pixel, and nothing is off. I can show you an example, so maybe it will be clear after that. So let's say we have an element, and we will fix its alignment. So let's say it's 6 pixel, 5 pixels, yeah, 5 pixels, and the negative margin to compensate. Then we have the next element, and when we add it 6 pixels, and then the bottom margin, we can see that again everything is properly aligned, and the text sits on the lines of the grid, and the element, the green element, is positioned properly as it was before we started applying these adjustments. So, so this approach works quite well, and yeah. So the summary is that we apply both top and negative bottom margin, and we do not use any margins anywhere else. And if we stick to these rules, it works quite well, because we have margins used exclusively for these adjustments of the alignment. We don't use margins for anything else. We can use paddings if we need to make like space between elements. And this is much simpler than the previous approach, where we had like a mix of paddings and margins, and we had to adjust when we wanted to apply some padding to an element. So so this is working quite well. There are some very rare cases where it breaks, and I will show you one case where it breaks, and we have a workaround for that. So the one case where it breaks is when we have an element with a background and without any paddings or borders, and we apply rhythm to the child of that element. So because of what we've shown with margins in this example, the margin of a first child like somehow goes out of the parent element. So this is what happens here. And there are several ways to fix that in CSS. One of them is to use overflow hidden, which is a hack, and it has some like other properties which are quite often non-desired. So I found another hack that looks a little bit ugly but works, and so far I haven't seen any problems with that. And the hack is to apply very small padding. And this padding is not visible, but it causes the margin to be placed within that element. So that's one of the drawbacks of this approach, but overall it works quite well. And basically that's what I have today to present. I will share the links to this article and several other articles on the topic. Especially this one, I think, is a very good explanation of the whole system. So that's it. Do you have any questions or maybe something to add? Okay, I guess you don't have any questions. I hope it was clear enough, and thank you for your attention then.